Good morning, guys. So today is Wednesday, April 29th, 2020. So over the last 2 days, I've had you reviewing how to solve a two-step equation and also how to simplify an expression when you have to distribute and combine. Today, we're going to learn how to solve equations using combining and distributing. So whenever you have an equation, the first thing you want to look for is distributing. Do you need to simplify that equation by applying the distributive property? And remember, distribute means that you are multiplying your outside number by the with the terms that are inside the parentheses. So if I look at question number 1, I have 2 times x plus 3 plus x is equal to 63. If you notice that 2 is multiplying with the x plus 3, so I need to make sure that I apply the distributive property. So the 2 would multiply with the x, the 2 would multiply with the 3, and that would give me 2x plus 6, because remember it's multiplying with both. I bring down my plus x equals 63. Then I want to look to see, do I have like terms to combine? If I do, I would need to apply that. So combine like terms. So in question number 1, I see that I have 2x and I have x. 2x plus x would be 3x, because remember, when the variable does not have a coefficient, it's an invisible 1. So you want to make sure you put it there so you don't forget that. So that's going to give me 3x. I bring down my plus 6 equals 63. Now you should have everything simplified where you can solve your equation. So we're going to solve the equation using inverse operations. So here is your equal sign. Remember, your equal sign separates your two sides. You always have to start by getting your variable term by itself, which means you need to eliminate that constant. So I do the opposite operation. The opposite of adding 6 is subtracting 6. And I have to make sure I do it on both sides so my equation stays equal. So I take away the 6 from the left side, and that leaves me with 3x. Then I'm going to take away 6 from my right side, which would give me 57. So right now I have 3x is equal to 57. So now I need to do my last step, which is to solve for x. So since 3 is multiplying with x, I have to do the inverse and divide by 3. Whatever I do on one side, I have to do on the other side. So the 3's divide out, leaving us with x. 57 divided by 3 would be 19. All right, so let's move on to example number 2. So we have 6x minus 3 times x plus 7 equals 6. So I have this 3 multiplying with the x plus 7. It's a negative because of the minus sign in front of it. So I have to make sure I apply that to both of my terms. So the 6x would get brought down. Negative 3 times x would be negative 3x. Negative 3 times 7 would be negative 21. And I bring down my equals 6. Now I have to combine like terms. So I have 6x minus 3x, which would give me 3x. Then I bring down minus 21 is equal to 6. Now I can solve my equation. So remember, your equal sign separates your two sides. I have to get the 3x by itself by getting rid of my constant. It's being subtracted from 3x, so I have to do the opposite and add it to both sides. 21's eliminate because they're opposites. I bring down 3x equals, now I'm going to add 6 and 21, which would be 27. 3 and x are being multiplied, so now the inverse would be to divide by 3 to get the x by itself. 27 divided by 3 would be 9. So I get my solution of x is equal to 9. All right, question number 3. We have 0.2v minus 5 plus 0.3v equals 1. So I have to start by distributing the 2/10 to the v and the minus 5. So that's going to give me 2/10 v minus 1 plus 3/10 v equals negative 1. Now we're going to combine our like terms. So I have 2/10 v and 3/10 v being added together, which would give you 5/10 v. Bring down my minus 1 equals negative 1. So now I can solve this using my inverse operations. So I have to get my 5/10 v by itself by getting rid of that minus 1. So I do the opposite and add 1 to both sides. So minus 1 plus 1 eliminates. So I have my 5/10 v is equal to negative 1 plus 1 would be 0. Now I have to get the v by itself by doing the inverse of multiplication, which is division. So I'm dividing both sides by 0.5, and that would give me v is equal to 0, because 0 divided by 0.5 is 0. All right, and question number 4. So we have 14 equals negative a plus 1 plus 8. So right now in front of the parentheses, there's nothing but a negative, but remember, that means it's a negative 1. So that's going to have to multiply with both those terms in the parentheses. So the 14 gets brought down, equals negative 1 times a would be negative 1a. Negative 1 times positive 1 is negative 1 because you have an odd amount of negatives. Bring down my plus 8. Now I want to combine my like terms. So my like terms here are negative 1 and positive 8. So 14 gets brought down, equals negative 1a gets brought down. Negative 1 plus 8 is positive 7. They're being subtracted because they're different signs, but since 8 is greater, I'm keeping the positive sign. So now here's my equal sign. Remember, you're getting the term with the variable by itself. So I want to get the negative 1a by itself, but the 7 is being added to it. So I have to do the opposite and subtract that from both sides. 14 minus 7 is 7. Bring down my equal sign. Bring down my negative 1a, because now the positive 7 and the negative 7 were eliminated. So now I have negative 1 multiplying with a. I want to have just what a is. So I have to divide both sides by negative 1 because it's multiplying with the a. The negative 1 eliminates, leaving us with a equals 7 divided by negative 1 is negative 7. All right, so now I'd like you to complete the try yourself problems. Remember, for each equation, you want to start by looking to see, do you need to distribute? And remember, you're multiplying all the terms inside the parentheses by the outside number. Then you combine your like terms, if you have like terms, and then you would solve your equation using inverse operations. If you have any questions, just make sure you send me a message. After you have completed your try yourself questions, you have to make sure you submit your work to me to get credit. All right, have a great day.